All right, so Algebra 1, Unit 7, Lesson 7. So we are rewriting quadratic expressions in factored form. So this is part 2 of what we just did in Lesson 6. So sums and products. So sums, basically you're combining, you're adding, um, and products, which means multiplying. So the products are the product of the integers 2 and -6 is -11. List all the other pairs of integers whose product is of -12. So go ahead and try to do that one. Go ahead and pause it and try to do that one on your own real quick. Okay, so hopefully you paused it and you tried to find all the other multipliers of -12. Um, what'd you get? Let's see. Um, they already did 2 and -6, didn't they? Um, Could we also do, and wait, -12, right? So what about 1 times -12? What about -1 times +12, right? What about -3 times 4? What about, let's see, there we go. There we go. And what about +3 times -4? Um, they did 2 times -6. What about -2 times +6? All those different pairs could have given you a product of -12. So number 2, of the pairs of factors that you found, list all the pairs that have a positive sum. All right, let's go ahead and highlight those. So -2 plus 6 is +4. 1 plus -12 is -11, so no. -1 plus 12 is +11. -3 plus 4 is +1. 3 plus -4 is -1, so no. Negative sums. Now they're asking about the negative sums. Um, 2 and -6, right, would definitely give us -4. I should not use purple. Excuse me, had to sneeze. All right, let's use blue. 2 times -6, right, is -4. So that's a negative sum. 1 plus -12 is -11. And 3 plus -4 is definitely negative as well. Okay, so 7.2, negative constant terms. So these expressions, like the ones we have seen before, okay, and I believe we did this with the table, right? And you could always use the good old-fashioned diagram if you need to, okay? So that's the diagram if you need to do that. Um, x times x is x squared, right? Um, x times 6 is 6x, right? And 5 times x is 5x. 5 times 6 is 30. We can combine the x's, can't we? So we technically have x squared plus 11x plus the 30. So that would be my answer for the first part of that table. Go ahead and work on these tables, okay? You can always use a diagram from lesson 6 that you saw there, okay? If you want to work backwards, you totally can. All right, so another example, we have x squared and 30 and 13x. So what can we combine that gives us 13x? But those two numbers, okay, um, have to be a product of 30, but at the same time have to sum to 13. I know that 10 times 3 gives us 30, right? So what about this? So we have x, right, times x gives us x squared. And we know that 3 times x is 3x. And we also know that x times 10 will give us 10x. And 3 times 10 is 30. And the x's add up to the 13x. So you actually end up getting x plus 3 times x plus 10. So notice how you can even go backwards with your diagram. Nothing is wrong with doing that. Okay, so that's how I got that there. So go ahead and finish these tables, or at least number one's table, and I will go on to number two. Okay, so number two, um, notice how it's a little bit more interesting. We had positives and positives, we had negatives and negatives. Now they're mixing it up with positive and negative, right? So draw a diagram might help. We have x plus 12 and x minus 3, right? That's x squared. That's negative 3x. That's 12x. And this is negative 36 because negative 3 times the positive 12. All right, if you combine the x's, right, you'll have x squared. 12x minus 3x, you should get what? 9x. And the negative 36 will be there. All right, so go ahead and go reverse and see what you get, okay? All right, so hopefully you paused it and you tried to do this reversed using the diagram. All right, I'll do the first one only. You get x squared, uh, get the negative 36, but it has to add up to negative 9x, right, for your middle term. What would do that? But at the same time, okay, it has to be a product of 36. So I know that 3 times 12 gives me 36, and the difference between 12 and 3 is 9, but it's a negative 9x. So the bigger number there has to be the negative. Does that make sense? So let's see here. This has to be an x, and this is an x. So you have x times x gives us that. We have negative 12, right? Because negative 12 times x is going to give you negative 12x. And x times what? 3? And that makes perfect sense. So your answer here is x minus 12 times x plus 3. All right. So that's how I found the reverse. Okay, so go ahead and do the rest of the table, and you can go ahead and try to use the diagrams from what we just did. Okay, 7.3, factors of 100 and negative 100. So with this one, we have to think of all the different types of pairs that would multiply to give us 100. Um, so we actually have to be pretty thoughtful here. So first things first, it has to give us a positive middle value. That means this number, when you combine the x's, have to be positive. So I know that 10 times 10 will give us 100. And if you were to add them, they give you 20. We know that 20 times 5 would give us 100. And if you add those, it would give us a positive 25. We know that 25 times 4, right? It's like 4 quarters, will definitely give us a dollar. And if you add those two factors, it'll give you 29. We got 50 times 2, that gives us 100, right? Because we're trying to get 100 here. And if you add those up, you get 52, positive, of course. And then finally, 100 times 1, you add those up, you get 101. Now, what if b was negative, right? What if it was negative some value? Does everybody agree that negative times a negative is a positive, right? So negative 10 times negative 10, it's going to give you a positive 100. But if you add them together, you get negative 20. All right, so negative 20 times negative 5 gives you negative 25. Negative 25 times negative 4 still gives you the positive 100. But if you were to add them, it gives you 29, negative 29. We got negative 50 times negative 2 gives you a positive 100 still. But if you add them, it gives you negative 52. And then, of course, if you realize the pattern, There's a lot of similarity between these two. Okay, they still give you factors of a positive 100, but if you were to add them, well, your b value is definitely different. Okay, so I want you guys to go ahead and try doing this. Let's see. It's a negative 100. Do you guys see that? Negative 100, not positive like last time. So I know b has to be positive for this table. So positive 25 times a negative 24 multiplies to get you the negative 100. But if you were to add them, it gives you a positive 21, right? Um, if your b value was going to be negative, you would definitely do something like this: 25, negative 25 times 4, that gives you the negative 100. But if you were to add them, it gives you negative 21. So I'll tell you what, go ahead and finish the rest of the table and kind of compare what you notice. Okay, all the factors of 100, but your b has to either be positive or negative for those tables. Number 3, write each expression in factored form. If you want, go ahead and try those on your own and pause the video. All right, so hopefully you pause the video and you got something like this. We know it's going to be x plus or minus something times x plus or minus something to get you what you need. We know it's 100, right? But it has to add up to negative 25. And you can actually use the tables from earlier if you noticed, right? So negative 20 and negative 5, right, would multiply to get you a positive 100. But if you add those x's together, you get negative 25, right? Negative 25x. So that'd be the way to do that. So you could really use the tables from earlier to do this. This one's a little bit more interesting, right? A little different. But it still is going to be multiplying to get us, this time it's a negative 100, but it still has to add up to positive 15. What about the positive 20 minus the 5, right? Because that would be positive 15, but 20 times negative 5, negative 100. So go ahead and finish C and D. Now you saw some examples. And I believe that is the end of the video. Have a beautiful day.